Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 2, Quiz 1, Extra Practice Number 1 Solutions on Solving Polynomials. To solve this polynomial equation, let's first see if we can take out common factors. Does not look like we can, and there's not four terms, so factoring by grouping is not going to work, but we do have the pattern of x to the fourth x squared constant. That is quadratic form. So we can actually factor this like a regular quadratic, only we'll use x squared instead of x when we break this up. So let's see here. This is actually going to be kind of tricky to factor as a quadratic because we have an a value out in front here that's not 1. So I'm going to use the AC method to help me here. So we have 2 times negative 12, a times c. That gives me an AC value of negative 24. So now I'm looking for factors of negative 24 that add up to 5. So we've got 1 and 24. That's not going to work. Neither does 2 and 12. How about 3 and 8? Well, if I had negative 3 and positive 8, that would do the trick. So I'm going to split this middle term up then into negative 3x squared plus 8x squared. And at this point, I do now have 4 terms, so I can use factoring by grouping. The first 2 terms, I can take out an x squared. That leaves me with 2x squared minus 3. For the next terms, I can take out a 4. Leaving me with, again, 2x squared and minus 3. I can take 2x squared minus 3 out of everything, and now that leaves me with an x squared plus 4 in my other parentheses. And at this point, I'm just going to set each of these equal to 0 and solve. So for this first one here, if 2x squared minus 3 equals 0, then I can add 3 and divide by 2 to get 3 halves on the other side. But that's what x squared equals, not x. I still have to square root this. If I square root this, I've got a plus or minus, and then I have a plus or minus radical 3 over radical 2, which I can simplify by multiplying by radical 2 over itself. So that would give me radical 6 over 2 plus or minus that. Okay, so those are 2 of my solutions. Now I know from the fundamental theorem of algebra that my highest exponent here tells me how many possible solutions I should have. In fact, how many total solutions I should have if you factor in imaginaries and duplicates. So I should get 2 more out of this next branch here. So if x squared plus 4 equals 0, I can say x squared equals negative 4. Square rooting both sides. I'm taking the square root of a negative, so there's an I coming out of there. And the square root of 4 itself is 2, so this is going to be plus or minus 2i. To solve this problem, I first look to see if I can take a common factor out of everything. It doesn't look like I can, but I can try factoring by grouping since I've got 4 terms. So for these first 2, I can take out an x squared, leaving me with 5x minus 7. For the next 2, I can take out, looks like a negative 7 would do it. That leaves me with a 5x and a minus 7. Now I can factor 5x minus 7 out of all that, leaving me with x squared minus 7 in the other parentheses. And at this point, I'll set each of these equal to 0 and solve. So if 5x minus 7 equals 0, then I can add 7 and divide by 5 to get 7/5. And we could also say for this next branch here that x squared has to have a value of 7. So square rooting both sides, I'm going to get a plus or minus radical 7. To figure out the remainder from this division and all this other stuff, we have to use synthetic division. So let me start by writing the coefficients of my dividend here. That's going to be a 2 for the 2x cubed, a minus 5, a 19, and the negative 16. Since there were no missing terms, that means I have no placeholder zeros I have to worry about. Now for my box number, that's going to be whatever zeroes out this divisor here, which is going to be positive 2, so 2 minus 2 equals 0. And then I'll leave a little space, draw a line, and I'll bring down my first coefficient. So I've got this box number getting multiplied by all these bottom numbers. So 2 times 2 gives me 4. Those numbers are going to go in this second row here. So we have a 4 underneath the negative 5 in the next column. And now I add these top 2 rows to get the rest of the bottom row numbers. So negative 5 plus 4 is giving us negative 1. 2 times negative 1, that gives us negative 2 up here. 19 plus negative 2 is 17. 2 times 17 is 34. And negative 16 plus 34, that's going to be 18. This last number here is our remainder of 18. Since that is not 0, that means that x minus 2 is not a factor of this larger polynomial. And for the quotient, that's all the other numbers down here that are not the remainder, starting one exponent lower than what we started with the dividend. So if you started with an x cubed, that means your quotient starts with an x squared. So this 2 really represents 2x squared. And this negative 1 really represents negative 1x. And then this 17 is just the constant plus 17. For this problem, let's use synthetic division to find all this information. So let's start with the coefficients of our dividend. We've got a 1 for the 1x to the 4th, followed by a 2. And after that, well, we're missing an x squared in here, so we need a placeholder 0 to hold that place. It's like having a 0x squared. And then we have a 40 for the 40x, and a 32. Box number on this one is going to be negative 4, because that zeroes out the x plus 4 here. So we leave some space, draw a line, bring down our first coefficient of 1. Negative 4 times 1, that gives me a negative 4 up here. 2 plus negative 4, that's how we're getting these bottom row numbers now, is adding these top two rows. 2 plus negative 4 is negative 2. And now we keep multiplying the box number by the bottom row numbers. So negative 4 times negative 2 is 8. 0 plus 8 is 8. Negative 4 times 8 is negative 32. 40 plus negative 32 is 8. Negative 4 times 8 is again negative 32. Hasn't changed in the last 10 seconds. But 32 plus negative 32, that is 0. So we have a remainder of 0, that last number down there. That tells us that since it's 0, that means yes, x plus 4 is a factor of our polynomial. And our quotient is going to be 1, using these numbers that are not the remainder. It's going to be 1, x to the 1 exponent lower than we started, so 1x to the 3rd power, followed by this negative 2x squared, plus 8x to the 1st power, plus 8, and that's it. For this problem, we're given this polynomial, and we want to write all the possible rational roots for it, and also find all the complex roots. So starting with the possible rational roots, those are going to be all the combinations of factors of the constant and factors of the lead coefficient, all of them in fraction form. So I'll have a numerator, and this will all be plus or minus all of this stuff. So we've got factors of 20, which are, of course, 1, and then 2 goes into 20, 4 goes into 20, 4 times 5 goes into 20. And then we're going the other way now. 2 went with 10, and then 1 and 20 also made 20. Next, factors of the lead coefficient 4 here. That's going to be 1, 2, and 4. And we actually have to put all these together into single fractions or integers. So we're going to have plus or minus, and now we're going to have all of these numbers in the numerator divided by 1, which is just all of these numbers in the numerator. So 1, 2, 4, 5, 10, and 20, because these are really all over 1. Next, I'm going to have all of my numerator numbers over 2. So we've got 1 over 2, haven't seen that before. 2 over 2 is just 1, so we're not going to write it twice. 4 over 2 is 2, don't need to write that. 5 over 2 is unique. 10 over 2 is 5, already got it. 20 over 2 is 10, already got it. Next, we're going to move on to all of these numbers up here divided by 4. So we've got 1 over 4, which we haven't seen yet. 2 over 4 is just 1/2, we've seen that. 4 over 4 is 1. 5 over 4 we haven't seen, so we'll put that in there. 10 over 4 reduces to 5/2, which you've already got. 20 over 4 is just 5. So this is our complete list of possible rational roots. At this point now, to find the complex roots, we're going to start plugging these into the polynomial using our calculator until we get a result of 0. So let me bust out the calculator here. So here's my calculator. To make my life a little bit easier, I'm going to enter my function into the y equals. So let me do that off camera. All right, I've got that whole thing entered in my calculator, ready to go. At this point, I'm going to plug all these numbers into this function until I get 0 back. And to make this process a little faster, I'm going to go to second table set, and I'm going to do, for independent down here, I'm going to do ask. That's going to allow me to plug whatever numbers I want into a table, and it'll give me the result in the table. So now let me go to table, and I'm going to start plugging in some numbers here. So if I plug 1 into my function, let's see what I get. 1 gives me a result of negative 11, which isn't really what I'm looking for. Let me try negative 1 plugged in there. That gives me negative 51. Still not quite what I want. All right, let's try 2. Ooh, that gives me 0. Okay, so we tried 1. That didn't work. We tried negative 1. Didn't work. But 2 gave us a result of 0. Now that I've shown that p of 2 is 0, I'm allowed to go ahead and plug in 2 using synthetic division on this polynomial. Now my goal here is to use this root that I know is a root to break this down a little bit further and factor it into something a little bit more bite-sized so that I can keep working away at this thing. So let me set up synthetic division. Let me write my coefficients here. 4, negative 11, positive 16, and negative 20. And let me set up my line here with a little box for my plug-in number, which is going to be 2 in this case, because that's what gave me the 0 when I used my calculator. So synthetic division time, let's bring down the 4. Times 2 gives me 8. Plus negative 11 is going to be negative 3. Times 2 is negative 6. Plus 16 is 10. Times 2 is 20. And yes, we get 0. So that works out. Awesome. But what I'm really interested in is these other numbers here that give me my quotient. So based off of what I've written here, I can factor my polynomial into x minus this box number of 2 times, and now this 4 is going to represent 4x squared. It's one exponent lower than the polynomial started with. So we've got 4x squared minus 3x plus 10. And at this point, I've got a choice here if I want to try factoring this quadratic or if I want to go ahead and use quadratic formula. And I'm thinking that I'm going to go ahead and use quadratic formula. I might be able to factor this, but it looks like it's going to be a bit of a pain. 4 and 10 are not prime numbers, so let's just use quadratic. So we have negative b plus or minus square root of b squared minus 4ac all over 2a. So that's going to be negative 3. That's our b value is negative 3. Plus or minus the square root of negative 3 squared minus 4 times my a value of 4 times the c value of 10 all over 2 times that a value again of 4. Simplifying this a bit, this is going to be positive 3 out here. Inside the radical, I've got 9 minus 160. So that's negative 151 inside the square root, plus or minus that. And then down below, we've got 8. So I'm almost ready to actually simplify this. I only have one more step to simplify it. So let me write my solutions over here now. So we've got x minus 2 giving us a solution of 2, because 2 minus 2 equals 0, and 0 is this whole thing out. And then we have the solution from my quadratic formula. I can take out an I here and write 3 plus or minus I radical 151 all over 8, which I cannot reduce any further. So these are all my complex roots.